So what I'm going to cover for the next 10-15 minutes, I'm just going to give an introduction to occupational disease in the downstream oil and gas industry, which is really what ENOC deal with. So just looking at the general health risks, perhaps the more obvious one, although relatively rare, just things like trauma, things like fire and explosions, and we do regular drills and practices and systems of that. So picture on the top right shows a big fire exercise, fire drill, and in fact our firefighters probably have one of the highest standards of fitness throughout the business in terms of testing and keeping them up to speed. Workplace exposures of interest, chemical agents, benzene, classical one. Interesting things like isocyanates, we do things like painting of cylinders and coatings, and that's another interesting challenge. Physical agents, very typical for the region, heat, noise. There's it's above ionizing radiation, certain parts of it's non-destructive testing. And then your classical ergonomics, things like manual handling, there's a lot of lifting and shifting going on. And things like computer workstations. We've got a lot of people work in offices, and the computer workstation itself remains a significant challenge in terms of health in the workplace. So, in terms of integrating the health into the risk management system, first of all, we're involved in hazard recognition. So that's getting guys out there and actually doing a recognition and risk assessment in the workplace. That can involve things like a walkthrough, where someone actually goes through and walks through the process in the workplace. We can escalate it to a higher level where we actually have an industrial hygienist doing a survey, and that's the picture in the top right hand side. That's a noise survey going on in one of our construction sites. So we can take it from basically a visual inspection, document inspection, to actually a level where you take measurements if necessary. We bring in control measures, and that's based on the risk assessment. From that we can carry out health surveillance. UAE law requires health surveillance every 6 months for a number of exposure categories, including benzene, asbestos, silica. And then tagged on to that as part of the health surveillance, we're looking at a fitness to work. And the fitness to work works in two ways. It looks at where people have been exposed to hazards in the workplace, how does it influence their health, has it impact on it, and are they fit to continue working with these substances? And then alternatively, look at someone's health and how that may impact on their ability to carry out work safely and efficiently. So do they have a condition that can impact? Diabetes, a classic one for working in heat. It impairs your ability to tolerate heat, so they have to have restrictions on it. If it is safety critical, may they become temporarily unconscious through a medical condition, therefore are they actually fit to carry these things out? So it's relating their health conditions to their ability to carry out work safely and effectively. Second on then, industrial hygiene. That's really the top end of the risk assessment. So if the risk assessment indicates that there may be a high level of exposure to a hazard, be it physical, chemical, biological, may be necessary to actually carry out more detailed risk assessments. So that looks at recognition of hazards, it assesses the risk, and again from the hygiene side of it, it will look at the control measures and give more detailed requirement of how that works. Top right hand picture, that's actually on a drilling rig, not just the downstream, but that gives you an idea. What you've got there is mud coming out of a drilling well. So again, all sorts of interesting toxic chemicals floating around in there. And then as part of the industrial hygiene, you can look at you actually take samples and take measurements. There are systems for doing that, how you select the sampling points, how you cover areas, how you cover the time, how you cover activities. It can be done at a personal basis or looking at an area. So you can look at an individual going through a process and take measurements as they do that. So you can look at what that person gets. Alternatively, you can actually look at an area and look at how the exposures pan out in the area. And you can bring the two together. You select individuals who are typical of what's going on in the process to get individual exposure. You can also derive what may happen in that workplace by taking samples at specific points, and then you can actually map it. So you can work out the high levels, low level areas, and then use that as a predictor. Common things that we measure in the workplace, chemicals, we're doing benzene fairly commonly, perhaps the most common one we've looked at. We've looked at isocyanates and various other chemicals. Noise, one again we're fairly well involved with, it's fairly straightforward. Ionizing radiation, you see a little badge on the bottom right, that can be used on a person. You can get instruments that actually measure radiation and different types of radiation. And again, you can do mapping. Non-destructive testing, again, as I said, that's one of the key ones that we do for checking for welds on pipes. From that, then, we look at general health surveillance. As I mentioned earlier on, first of all, we can look at general fitness for work. So we know what their job is. Someone comes in, we check them out, check what health conditions they have, how well controlled they are. Do they impact on that person's ability to carry out their work? Is it well controlled enough? Do they need to have restrictions or modifications in terms of the work to make sure they can do it safely? We then do job-specific health surveillance. Mentioned earlier on the firefighters. These guys carry heavy gear around. They're running in this full kit. It's very difficult for them to actually lose heat in these circumstances because of the various levels of clothing they've got on. They're carrying heavy loaded hoses. These hoses, when they're full of water, are even heavier than blank. They are carrying this stuff up and down ladderways and things, so it is physically strenuous. So it's not, from our point of view, it's not simply a case of the medical, but they actually have a physical fitness evaluation, what we call a VO2 max test, and that checks their aerobic fitness, and there's a standard for that. They have to pass to be able to do this safely. We can then look at exposure-specific medicals. As I said, this follows the UA law. So we're looking at benzene here is a common one, so we'll do urine samples for breakdown products of benzene, and this is every 6 months. And then we do other exposure-specific screening tests, not necessarily required by UA law, but required by good practice. And again, noise, we've got a hearing conservation program in place. So, and I know one of my colleagues is going to talk about hearing conservation a bit later on in more detail, so their aspect. And the bottom right, that's a step test. So checking for aerobic fitness, dead easy. They step up and down, and they go faster and faster and faster to the tune of the music. You check their pulse rate, plot it off, and that gives you a VO2 max. So this bit of kit's dead easy. You can take it around onto sites. You'll need a small area to do it from. Don't have to do it in a clinic. But it's a very, very useful tool in checking the aerobic fitness of these guys. Seen it more commonly in divers now as well. This out of interest in other fields where physical fitness, as opposed to medical fitness, is an important criteria. So the sort of physical hazards that we see downstream, heat stress. I'm sure you're all fairly familiar with this, but let's go through it again. So the sort of things when that gets out of hand, we get fatigue, going on to exhaustion, which is more severe. They can get cramps, and in the worst case, they get what we call heat stroke, where you get total collapse, and various organs in the body will start to fail. So the key part here is to keep an eye on exposure, to monitor what's going on in the workplace. You can plan potential exposure if you expect people to go into hot places, into confined spaces, into furnaces, and various other issues like this. Again, you can work out what's going on in the future, and in fact there are models that you can use to plan and limit the exposure before they even start. It takes into factors airflow, temperature, humidity, and you can incorporate the type of clothing they're going to be wearing as well, because that may impact on their ability to tolerate heat. Plenty of fluids, can't stress this one enough, really key to it. We can look at their fitness to work. There are various physical parameters and medical parameters that may impact on their ability to tolerate heat. Diabetes, as I said, is a classic one. Extensive burns, where you've got scarring and people can't sweat, another one. And a whole variety of medications that affect blood flow to the skin and the ability to sweat. And they can impact on tolerance to heat as well, so it's important to pick these things up. And then, notwithstanding that, you need to have first aid, treatment, emergency systems in place. So if it goes wrong and someone collapses, they get treatment quickly and effectively. The slide we got on, the picture on the slide here, is a backpack for water. And this is a gadget that was developed for the military in Iraq. And they basically can carry it, it's called a camel pack. literally like a camel with a hump on its back carrying the water around, same thing. So they can carry a reasonable amount of water, keeps your hands free, and there's a little device on the side there that you can suck the water out of. And in fact, you can also cool the water down by putting ice into the pack as well. So it's something that we've got for some of our workers out in more remote sites where they can't keep going back and picking the water up from various things. They can actually carry it around with them. So just an example of making sure these guys get sufficient fluids. Noise, as I said, one of my colleagues is going to go into a bit more detail later on, but we're obviously concerned about noise-induced hearing loss. It occurs initially around the 4 kilohertz, and you can see the dip on the bottom picture there on the audiogram. That's where it's occurring. It causes problems in communication and problems in hearing alarms. So there you get miscommunication where people don't hear things properly, they do the wrong thing because they've not understood the instructions, and in severe cases they may not be able to hear alarms warning them to get out. One of the big risks that we've got on some of our sites are the reversing or transport alarms from forklift trucks. So if that comes around and someone can't hear it, that increases the risk of them having an accident with these vehicles. So it can be very important. We look at reducing the noise at source. Hearing protection is the last in the hierarchy of controls. So, get it at source first. And then part of the screening program that goes with that is audiometry. The top picture there actually shows noise mapping. So I mentioned earlier on about doing hygiene mapping. We can do this with noise. And in fact, we can do it in 3 dimensions. So you're not going to have a flat map just looking at the ground area, but if your building goes up, noise travels in all directions. So in fact, a noise source on the ground may reverberate through the upper levels as well. So by taking these various points, we can actually do 3D mapping and work out the quiet routes through and in fact identify where noise sources are and try and mitigate the source. Ionizing radiation, naturally occurring radioactive material, comes up with the oil, gets into various precipitators, gets into various cleaning systems, and that's the top right-hand thing. And in fact, this stuff precipitates out and can actually clog pipes up. So you see that was probably around 4 or 5 inches across, and you've got less than an inch of pipe left now, just because this material is deposited inside it. But it carries the level of radiation and can be an issue. Non-destructive testing, so we do a lot of that in terms of looking at pipes. With the radiation, if you get intense beaming, you can get local effects. The middle picture's a radiation burn on a hand. That shows you the amount of tissue damage that you can get from it. Longer term effects, all well aware cancer's a potential big risk. In terms of managing ionizing radiation, the principles are fairly simple. We work on time, distance and shielding. Right, time, you spend as little time near the radiation as possible. Distance, you stay as far away from it as possible. And shielding is you put a shield between the radiation source and the individual, and the type of shield will depend on the type of radiation. We can look at dose monitoring. So again, that can be done individually, wearing the badge we showed earlier on. And in fact, there are various number of gadgets that you can use for actually going around a site and actually measuring it. And again, the gadget you use will depend on the type of radiation you're trying to measure. And then finally, we can look at fitness to work with radiation. Do people have conditions that make them more prone to having issues with it? If you have problems with skin, it can mean that material can get through the skin easier. It also makes it more difficult to wear PPE if there's skin conditions. So if you're wearing the big Tyvek suit to stop bits coming through, actually if you've got a skin problem, it makes it difficult to wear it. Mental health is another interesting one that comes up quite regularly. It doesn't necessarily make you unfit to work with it from an interaction point of view, but do you want someone with mental health issues running around with a radioactive source? So that's really how that one works. Benzene, my favourite, so I have to include this one here. We've done quite a bit of work on benzene, but it's an organic compound. It can have acute effects, affects the central nervous system in very high doses. At low doses, we get risks that are primarily looking at anemia and cancer. And in fact, not only causes anemia, but it affects the platelets which are involved in blood clotting and affects the white cells involved in fighting infections. So you can get what we call an aplastic anemia from exposure, where the red cells drop down, so people become tired, they can't carry oxygen well enough. The platelets drop, which means that they get easy bruising, and that can be one of the early signs. The white cells drop, which means they can't fight infections, so they get recurrent infections. And that coming together, a sign of aplastic anemia, which comes with benzene exposure. The cancer one is a form of leukemia, and it's well documented. So again, what we're doing and looking here is to try and control exposure by whatever means. And we use a hierarchy of controls. Do you need to use it? Can you substitute it? If you can't substitute it, you enclose it, use ventilation. And then at the final end point, we'll use things like PPE if necessary. Health surveillance is you can do blood tests to look for the secondary signs, which is things like the anemia and the platelet loss. But the urine tests we do end shift, and that looks for breakdown products of benzene, and that gives an indication of the level of exposure in the workplace to make sure that's well controlled. Isocyanates mentioned earlier on, using paints and fillers. Picture there is one of our guys at the cylinder factory spraying isocyanate paints on a cylinder for containing gas. You can get acute effects. It can cause respiratory problems initially. The classic thing with isocyanates is asthma, occupational asthma, and it doesn't take particularly high doses to sensitize people, so it is an issue. Basics here, we look at controlling exposure and taking high levels to control exposure contained systems, and then we'll look at health surveillance for individuals working with it to make sure that it is working. So that's primarily looking at their lung function to make sure there is no sign of restriction in the lung passages.
Mark, can we deal with one more hazard and then maybe we'll take a few questions?
Yeah, sure, hang on.
Thanks very much.
I'll tell you what, let's go back to what I've got there. Sorry. Computer workstations, probably over a third of our workforce involved with computer workstations for the main part of their job. Issues here, musculoskeletal pains, visual problems. The main thing is to adjust the workplace. It is relatively simple to do that in theory. In practice, getting people to adjust their workstations correctly can involve a huge amount of effort. You can train employees. You can look at health surveillance to see whether there are any issues that may impact on their ability to use them properly. And you can do adjustments in the workplace. Get it right, it works really, really well. It's just getting the employees engaged to do this. So we'll get some questions, there we go. I've taken the hint from our glorious leader here, so any questions on any of that?